Learning Task 2.1, Question 6.36. Predict the reactions of the following hydrogen compounds with water and explain the reasoning. Letter A, calcium hydride, B, hydrogen bromide, C, hydrogen sulfide, and D, methane. So for letter A, since calcium has a lower electronegativity than hydrogen, it causes the hydride ions to interact with water. Hence, the ion of calcium is formed and hydrogen is in the form of gas. For letter B, bromine is more electronegative than hydrogen. So hydrogen ion reacts with the water molecule. And here, hydrogen is highly positive and rapidly transferred to the single pair of water because it is more electronegative than bromine. For letter C, since sulfur have a more electronegative advantage over hydrogen, or it is slightly more electronegative than hydrogen, the positive hydrogen ion reacts with water molecule, but the reaction is in equilibrium. Lastly, for methane, the contact between oxygen atom of water and the carbon-hydrogen bond necessary for hydrogen ion transport is very weak, since carbon-hydrogen bond is essentially polar. So methane is a non-polar compound and it does not dissolve in water. Therefore, there is no reaction. Question 7.14. Comment on the trends in the following values for the interionic distance. So first we will observe the changes in the interionic distance from left to right, then from top to bottom. Interionic distance increases from left to right except for this part, which is sodium chloride to silver chloride, and sodium bromide to silver bromide. Interionic distance from left to right is based on the sizes of the monocat ions. Trend for monocat ion sizes is sodium cation is larger than lithium cation, and lithium cation is larger than silver cation. So here. It should be expected that the interionic distance increases from lithium cation species to sodium cation species, then decreases from sodium cation species to silver cation species. This is coherent except for sodium fluoride and silver fluoride. Then, like I said earlier, we will also observe the trends from top to bottom. So from the top, interionic distance increases from top to bottom. Interionic distance from top to bottom is based on the ionic sizes of the monoanions. Trends from monoanion size is bromine anion is larger than chlorine anion, and chlorine anion is larger than fluorine anion. This is coherent. Coherent with the table shown in the PowerPoint. Therefore, interionic distance increases from top to bottom and from left to right, except from sodium chloride to silver chloride and sodium bromide to silver silver bromide. Question 8.9. Use the following experimental data to obtain the cell potential and comment on the need or not to make use of all the data given. So in this question, we will first need to know the half cell reaction, which is here. It is written in this form. This form. Then we will apply the Nernst equation for the half cell. The Nernst equation gives a relation between the concentration of the reactants and the products with the cell potential and standard cell potential. So this is the equation for the Nernst equation. Here, R is the molar gas constant, which is 8.314 joules per kilomole. Then T stands for the temperature in Kelvin, and here it is 298 Kelvin. F is Faraday's constant, which is 96,485 Coulomb per mole, and Z is the number of electrons transferred in the reaction. For this half cell, the value of Z is 2, and we will just put all of the values in this equation, and we have the concentration of copper, which is 0.001, concentration in oxidized form, while the concentration in reduced form is 1. So here the calculated cell potential is 0.3409 volts.